So we're in section 5.6, general factoring strategies. So step one, all right, whenever I'm trying to factor, what am I looking for? I don't care what type of problem we have. Yes, sir. The GCF. So step one, you always, always, always look for the greatest common factor. That's going to be the biggest piece to success on your guys' quiz and exams. Always looking for a GCF. All right. Was there any GCFs in this quiz you just took? Yes. All right. If you didn't pull it out, then life was hell. All right. Step two. What you want to do is count the number of terms in the polynomial. So you want to examine the number of terms. So you're going to see, do I have 2 terms? Do I have 3 terms? Do I have 4 terms? Because if you have 2 terms, right, let's look at that. What happens if you have 2 terms? What are some formulas that you guys have seen for 2 terms? Difference of squares, good. So 2 terms, you have option A, which is the difference of squares. Anybody use that for the quiz? Yeah, right? Difference of squares. All right, which says, I'll just make up a formula here. X squared minus y squared. That's the same thing as what? X minus y and, oops, that's a y. X plus y. So sorry, it looks like a G, but it's a y. All right. So that's our difference of squares. All right. We have another formula for 2 terms. What is it? All right. So we got a few. Good. So let me move this up. All right. So we have a few of them. So sum of cubes. Sum of cubes. And so what that looked like is x cubed plus y cubed. And I think I stayed away from this one on this quiz, yeah? Yes, you're welcome. All right. So that one was x plus y and x squared what? Minus xy plus y squared. All right. So that's a sum of cubes. And again, you use it when each one of these is a what? A perfect cube. So it has to come from that list that I gave you the other day. Right? It has to come from that list. All right. And there has to be a plus in the middle. That's why it's sum. All right. What's the next one? Sum of squares. So if we said you had something like this, x squared plus y squared, then right away we knew it was what? Prime. Prime. Know any of those answers prime?
Not yet.
Yeah?
No.
Nope.
Not yet.
Not yet.
I've created like 4.
How about the solutions? Any of the answers prime?
No.
No, because I saw a lot of people write prime.
Unless there's like invisible ones, I haven't gotten there.
Oh, okay, good. Oh, okay. So we got to be careful, right? What's the next? The last one. We have sum of cubes, sum of squares, difference of cubes. Difference of cubes. Difference of cubes. So that one looks like a cubed minus b cubed. So both of these are going to have to be perfect what? Cubes. Give me a number that's a perfect cube. 27. 27. 8, right? So you're looking for those type of numbers. How about letters? What are some variables that are different perfect cubes? A cubed. B cubed. Any others? Y cubed. How How about y to the 27th power? Yes, because all that it has to be true is the exponent has to be divisible by what? By 3. All right, so what does this formula look like? A minus b times plus ab plus b squared. All right. So there's the difference of cubes. All right. So what I'm going to do is I'm going to change up my script. I have some notes, but again, based on I always trying to learn from you guys, right? So I just learned something right now based on kind of the work that I saw and kind of the actions I saw. So what I'm going to do is I'm going to change up the script. So I'm going to give you a problem right now. You're not going to do it. All you're going to do is examine it, and you're going to tell me, can I use one of these formulas? Does that make sense? All right, here we go. So here's the problem. Here's my example. X plus 27, too high up. Only my people on YouTube could see that. All right. X plus 27, x to the 4th. All right. So before you talk about it with anybody, I want you to make the conclusion after you copy it down. Eventually, are you going to be able to use any of those formulas that you just saw? If you think so, write down which formula you think you could use. All right. So look at it, examine it. And as you're thinking about this, the hardest part of the exam is figuring out this first question. All right. So what do you guys think? Can you use one of those formulas? I hear yes and I hear no. All right. So this, let me be honest, on the test date, this decision has to be within the first 15 seconds or else you're going to make it harder on yourselves. Later on, we'll talk about why that is. All right. Because you're going to start to second guess yourself. You're going to start to do all these things. You're going to go into panic mode. All right. What's the first question you always ask yourself? GCF. Is there a GCF here? What is it? X. Always ask yourself that question. GCF. Write that down if you forgot to do that. Right? Right. Because here's the thing. I hear it all the time. I get nervous. Right? Even when I get nervous, I promise you I remember my name. Right? So what happens is you have to do it enough times that even if you, right, you have a gun to your head, you're like, okay, GCF. All right? All right? And that's just the way our brain works, right? You got to put yourself in a stressful situation where you learn this. All right? So here, now ask yourself, can I use one of those formulas? Yes. So you could have used one of those formulas. All right. So let me rewrite it. I want something cubed plus something cubed. I want something cubed plus something cubed. So you ask yourself, what cubed is going to give you 1? 1. What cubed is going to give you 27x cubed? 3x. So there's your A and there's your B from that formula that we learned last week. All right. What's going to happen to this x out here? You just continue to bring it down, right? Just drop it down, drop it down, drop it down. All right. Well, which formula am I using? Sum of cubes. So again, if you're just copying me down, man, we got some big trouble. Because these notes right here, the way I have them, those are lousy ass notes, right? So hopefully in my notes, I'm writing down, I got to use the sum of cubes because my teacher's too lazy to write it. I got to use, right? You're filling this up with all kinds of notes that are helpful for you, right? These are your notes. These aren't my notes, right? So tell yourself the story of what's going on. Because when you miss the story, right, once you're quizzed on it, then it's like, I forgot. Well, you never had a story to begin with, right? So it's very important. All right. So We have this x you told me comes down for the ride. And then, what does that formula say? It's what? Okay, so in this case, our a and our b is 1 plus 3x, right? Because we add a plus b, this guy plus this guy. And then we do what to the a term? You square it. So 1 squared, 1. What happens to our sign in our formula? Minus. What do you do with a and b now? You multiply. So what's 1 times 3x? 3x. What's my sign? Plus. And what's b squared? 9x squared. All right. So again, I promise you guys could do this. It just takes some time, right? Some repetition. Some repetition. All right. So talk now. What happens when you have 3 terms? And when we have 3 terms, that's called a what? A trinomial. A trinomial. All right. So what we want to do is, what do we do when we have 3 terms? I taught you a method called the what? Good. So I think we called it the new AC method, something like that. The new AC method. Anybody use that tonight for the quiz? Yeah? All right. So maybe we, anybody use a different method? Try on there? Grouping method? Cool. I forget. Did I send that video on the grouping method or? Yeah? Okay. So if you haven't checked it out, there's been some activity on Edmodo, right? Some videos have been posted and stuff. So if you haven't looked on Edmodo, there's a video on the grouping method. So make a little note of that. On Edmodo, there's a video on the grouping method. All right. But here's the AC method. All right. So here's my question to you. Can I use the AC method on this example? So here we go. We have 32y squared minus 48y plus 18. All right. Whenever I ask you to factor, so make sure you write that down, that we're going to factor this. We're going to factor this. All right. So when we factor this, if I just say the word factoring, right away you're thinking what? GCF, greatest common factor. So again, unless that's engraved in your brain, then write that down. All right, unless you got that down cold. So you're always looking for the GCF, the greatest common factor. What is it here? 6? Good. So we factor out the 6. You factor out the 6. All right. What's left in parentheses? Six y squared? No? It doesn't go into 32? So is there any number that we could factor out? 8? Does 8 fit into everything? No. 2. Is 2 the GCF? 4 doesn't fit into 18, right? So it's 2. But that's pretty deceiving, right? Because 2 is a small number. But 2 is like, shit, I'm the biggest number here, right? So never count 2 out. All right. So the biggest number to factor out is 2. So there it stands nice and proud. All right. What's left on the inside? 16y squared minus 24y plus 9. And all those other nice numbers I heard. All right. So now let's get to work. Let's do this AC method. All right. And here's the beauty of it. Are we allowed to use calculators? Yes. That's good. Man, it's going to make things so much easier. Because sometimes we see a big number, we get scared. Right? Don't worry about it. Just calm down. All right. So we do it. Let's do it. 16 times 9. Use that calculator. What is it? 144? Ooh, that sounds like a nice number. 1 44. What number do we put on the bottom? Minus 24. Ooh, that sounds like a nice number. All right, I could smell it. What are my two numbers? Negative 12 and negative 12. Nice. Very nice. What are we going to do now? All right, we put them in our parentheses, and we have y minus 12 and y minus 12. Let me go ahead and get some red action in here. I'll underline that in red. Why am I underlining the 16 in red? I kind of just wanted to use red, but yes. We're going to divide both of these 12s by this 16, the leading coefficient, as you guys are saying. Excellent. All right, here's what I saw on some of the tests people turned in, right? Right away, people will take this number and they'll bring it to the front, but what do you got to do first? Simplify. 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 So 12 and 16, I could divide both of those by what? By 4. So y minus, what does that new fraction turn into? 3/4. Y minus 3/4. All right. I cannot simplify any further, so where are those 4s going? To the front. To the front. To the front. To the back. All right. What do we need to bring down? The 2. Don't forget this 2. Bam. All right. So now that the 2 has joined us, what's left in parentheses? What's left in the 4y minus 3. 4y minus 3. And this is where the big question comes in. Go ahead and ask it. Good. There's 2 copies, right? There's 2 copies. So we could just write 4 minus 3 squared. All right. But let's back this up because someone has a question somewhere besides that. All right. So questions. Yes, thank you. That's okay like this right here. I'll accept it. Trust me, if you get to this point, I'll be very happy. All right. Other questions? The simplify. So what we're doing here is I ask myself, is there a number I could divide 12 by and a number I could divide 16 by? So that's what you're looking for. So, and it has to be the same number. So since I could divide both of them by 4, that's what we do. 12 divided by 4 is 3. 16 divided by 4 is 4. Does that make sense? Yeah. All right. Someone else had a question. Yes, sir. Oh, you always multiply. Let me bring this down. To get this guy right here, you always multiply the first term and you multiply that last term. So 16 times 9. That always gives you that number up here. Cool. Other questions? Yes.
Can you remind me, when are we supposed to divide by the coefficient?
Okay, so the question is, you can't hear in the back, what kind of Christmas presents I like. I'll be sending out an email. All right. So the question is, when do I know what number to divide by right here, right? Or when to divide by that number, yes? Whenever you have a coefficient right here, see how this one's 16? Whenever that's not a 1, that's when you do this division right here. Whenever it's not a 1. And you actually do it with the 1, but the 1 doesn't change anything. Yeah. Great questions. All right, how many terms do we have here? 4. So most likely, we got to use the what? The grouping method, right? So what we do is we first try it the way it is, right? We're going to group those 2. We group those 2, all right? This is going to work 70% of the time, all the time, right? So what do these first 2 have in common? The A. So I'll factor out the A. right? What do these second two have in common? 2, and we've pulled out the what? The negative. You always factor out that sign that's in the middle. So if you didn't know that, write that down, or whatever is going to help you understand that. So that sign in the middle always comes down, right? Whatever's in the middle is always what counts the most, right? Think of an Oreo, right? Think of a Twinkie, right? That's where all the good stuff is. It's in the cream filling. All right. Shit, I'm hungry. Anyways. Okay. What are we left with in here? X minus 16. What are we left with in here? X minus 16. The 8. Wait, which 8? Oh. So we pull out the A, and then all we're left with is the x squared. Oh, that should be squared. Man, why don't you guys tell me? X squared. It's because we wrote it in white. All right. Did anybody watch that video we made last time? Yeah. Did you guys notice there's a part that I was talking, but there's no writing going on? Yeah. Yeah, I played that for my students the next day, and then I kind of was just watching them, and there's a part where they're all looking at me like, what the fuck are you doing? I was like, why is everyone looking at me? Watch the video. And I looked at the screen. I was like, oh, shit. All right. So remind me tonight not to use white. All right. What do these guys have in common here? Bam. X squared minus 16. So what do I do with that? You factor it out. You factor it out. All right. So now we found that mother factor. All right. And then you're left with what? A minus 2. And now are you done? No? Shit, man. When are we going to finish? Why not? What formula do you use there? Difference of squares. Difference of squares. Right? Check it out. If you're kind of lost here, this is what I would be doing, right? Let me give you a pro tip when I was a student. When people are singing along with the rock, right? When they're answering my questions as I'm talking out loud, I would kind of pay attention to, oh man, that person over there knows all the answers. That's my new best friend, right? Next class, I'm jacking somebody's seat, and I'm sitting right next to that person, right? So be ready. Pay attention to all these little things. All right. I already seen that happen a bunch of times, right? So x squared minus 16. What are we left with? What here and what here? X and then plus 4 minus 4. Does the order matter? No, not order. Order. There we go. Order in the court. All right. Are we okay there? All right, let's do one more just to test you. What happened to the 2? This 2, right? This 2 went right there. All right. Here we go. Next example. Let's go big or let's go home. Here we go. 10y to the 5th minus 17y to the 4th. Oh yeah, now it's getting good. Plus 3y cubed. Right? This is the problem that causes students to look to the sky during the test. Right? All right. So this is one of those problems on the test that gets people overwhelmed. So take a deep breath and then look at your neighbor's test, see what they're doing. No, just kidding. So if you ask yourself the biggest question of all, then this isn't hard. What's the biggest question of all? GCF. What is it? Y cubed. If you want to put the y, go for it. A lot of you were thinking about me, so you put a number 1 right here. That's fine. All right. So y cubed. All right. So from each one of those, you're taking out 3 y's, right? Y cubed. 3 times 3, or y times y times y. So what am I left with in here? 10y squared, go on. Minus 17y, go on. Plus 3. Nice. Right? It was so nice that I see the sun there. All right. All right. Now we could use what? The new AC method. Some of you could use your old school trial and error method. If you watch that video, you could use the grouping method. All right. A lot of different methods. I just want you to learn a few and learn them really well. Right? So what number is going upstairs? 30. Don't forget, you do 10 times 3. 30. All right. What number is going downstairs? Negative 17. So my two magical numbers are? Negative 2 and negative 15. And they're both going to be negative because the negative times the negative is going to give me that positive. When I add them, they become bigger. Yes. This is Johnny's method. The new AC method. All right. So now we go ahead and start filling this in. So Karina, last time you asked me, I believe you asked. No, it wasn't you. Who asked me this? I'll remember right now. When do I have to divide these by something? That was you? Oh, okay. So I divide both of these by what? By 10. All right. So I divide them by this number that's right here. As long as that's not a 1, that's when I divide. All right. So can you simplify these? Yes. So we get y minus, what does the first one become? 1 over 5. What's the second one become? 3. No, you're good. 3 over 2. All right. Notice, I'm forgetting to bring what along for the ride? Y cubed. All right. No wonder it was looking at me all pissed. Right. So don't forget it. Y cubed. Bring it down. All right. So I bring it down, the y cubed. And now I figure out what's in my parentheses. So what's in the first one? 5y minus 1. This one always goes to the front. What's in this one? 2y minus 3. All right. We are now going to look at polynomial equations. For those of you that need to spell that out. Polynomial equations. That's my abbreviation. And applications. And get ready to get lost, some of you, because you're not ready. All right. So here we go. A polynomial equation. Check it out. If I could hear you, you're distracting a lot more people. A polynomial equation is an equation of the form, I can still hear you, of the form a polynomial equaling a polynomial. All right, so what we're going to have is we're going to have a polynomial equaling a polynomial. That's what we call a polynomial equation. All right. So that's the form we have. What we want is we want something called standard form. Standard form. And standard form is when you have a polynomial equal to 0. All right. So standard form is when you have a polynomial equaling 0. Don't worry, we're going to look at a lot of examples. All right, but this is what we want. This is the stuff you have to wrap your head around. All right. All right. And here's where the question goes. This is the part where you're going to try to do some homework, and this is where some of you are going to make the conclusion and be like, wait, he never talked about this stuff. And it's not that I never talked about this stuff. Here's the truth. You never understood this stuff because you're copying examples and you're not trying to understand. So stay with me. All right. Part C. A quadratic A quadratic equation is a second degree equation. And we're going to see what that means. That just means your biggest exponent, the largest exponent is what? Is 2. So if you understand, oh, a quadratic equation is a second degree equation, if that makes 100% sense to you, then you write that down. If that doesn't make any sense to you, then what should you have in your notes? A quadratic equation has the largest exponent of what? Of 2. So again, all this stuff has to make sense or else these notes are worthless. All right. So again, make sure all this makes sense. So a quadratic equation has the highest exponent of 2. That's what that means. All right. So let's look at a standard form. So I want to show you what standard form looks like. Standard form of a quadratic equation. Standard form of a quadratic equation. So we're going to look at standard form. And here we go. It looks like this. Ax squared plus bx plus c, and it has to equal what? It has to equal 0. All right, it has to equal 0. So that's going to be the general form. That's your goal right there. If it doesn't look like this, then it's your job to make it look like this. All right. Let me ask you a big question before we start. All right. Here's the big question. Let's put an example. If A times B equals 0, what does this mean? What does this imply? Good. A equals 0 or B equals 0 or what? Or both of them equal 0, right? Because if two things are multiplied and your answer is 0, that means one of those mother factors has to be 0, right? We're going to use this all day long right here, this little idea. All right, this is an idea we're really going to put to use. All right, so let's put it to use right now. Here's our very first example. But look what you did. You said standard form, it has to be equal to 0. That's what these notes are for, right? This is what people did. They looked at their notes and they said, if I have something times something equals 0, then one of these two things has to be equal to 0, right? That's how you use your notes, right? All right. X times a quantity x plus 9. I'll bring it down. And let's set that equal to 4 2x plus 5. All right, here's a fair warning. Today's homework. None of these problems are going to look the same, right? You're going to have to understand the big idea. I want this equation to, at the end, to be in what form? Standard form. So there is no recipe. There is no steps. You just got to do what you know how to do. So looking at this, what do you see? What can you do first? Distribute. So multiply. Rely on your skills, what you know how to do. So you distribute. All right. You got to start somewhere. All right. Someone had a question for me. And I said, all right, show me exactly what you did. They sent me a blank document. And I was like, oh, no, you just sent me a blank paper. They're like, no, that's what I did. Right? So you don't know where you're lost until you actually try something, right? So you got to actually try something, right? You can't just stay there. Even if it's wrong, then it'll help you think about, right, things. So now that I multiplied, what would you imagine doing next? Set one side to 0, right? I haven't taught you this, But look what you're relying on. So I have not taught you. So math is not about following 1,000 steps. It's about this is your goal. Go out there and get your goal, right? So here we go. Let's go out there and get our goal. So minus 8x minus 8x. Let's do this. And you're going to get 8x squared plus 1x equals 20. All right. And now is that standard form yet? No. So we subtract 20. We subtract 20. And the only thing you have to understand is that your goal is to get this one of these sides equal to what? 0. So the worst thing you could do is go home and try to practice exactly what we did here. The best thing you could do is understand my goal is I want one side equal to 0. All right. So I get x squared plus 1x minus 20. All right. Look where I'm at right there. All right, because I want you guys to come up with this. All right. So again, right now, some of us, I look around, some of us are in this mode right now. You guys ever see that movie Up? Squirrel. Right? You're distracting the shit out of yourselves. Right? Stay with me. Stay with me. What do I do now? Factor. So write that down. We factor. Right? Shoot ourselves in the foot. We factor. All right. So I go ahead and I factor. What skills do we have? What methods do we have for factoring? The AC method, right? We have some methods, right? So let me do this. If we had enough time, do you guys think you could factor that? I believe most of us in here would be able to factor that, right? So right now, do you realize the point of this lesson is not to teach you how to factor anymore? Now it's assuming that you're okay at factoring. Does that make sense? Okay, so let's not waste our time, right? I want to give you the stuff that you should be here for tonight. This is the process. So we factor, all right? And this is what we're going to be practicing over and over throughout the rest of this semester, all right? So that's why I gave you guys that project for Wednesday, because factoring, if you can't factor, then that's kind of the point where we should not continue with this class, because the rest of the class is going to rely on your ability to factor like nobody's business. So don't worry. If you can't factor, you just have to put some work into it, right? All right, so again, that doesn't mean don't start panicking. It just means get to work. All right. So when we factor, that's what we get. All right. So notice, I have something times something equals 0. So what did you just tell me when you had something times something equals 0? Good. So one of these guys has to equal what? 0. So let's write that down. Perfect. X plus 5. One of these guys has to equal 0. So either that's going to equal 0 or what? X minus 4 equals 0. Right? So one of those two has to equal 0. And notice, did I ever show you an example like this? Absolutely not. But check out what people did. Let me go back real quick. So that's how you use your notes. All right. So now what do we do when we have this part? This is the nice part. Good. Now we just solve. This is the nicest part of the problem. Now we just solve. So minus 5, minus 5. So we get x equals negative 5 plus 4 plus 4. X equals 4. So here we end up with how many possible answers? 2. So we're going to put them in our set. The smallest number first, then the second number right there. All right, questions. Please, yeah, just get in the habit of writing them as a set. Yeah, thank you. Other questions? All right. All right, so there's our next problem right there. All right. And what's the problem that we have with this one right now? It's not what? It's not in standard form. And what does that mean? It's not set equal to what? 0. So let's do that. Good. Perfect. Now we're speaking the language. It's not in standard form. So we're going to go ahead and make it equal to 0. And to be honest, what do you think? Does it matter which side you set equal to 0? No, you'll get the same thing. It might just be more work, but it's the same exact thing. So here's the thing. If I'm a rookie, I'm just copying down this, and this is all I'm copying down. With experience, what I want people writing in their notes, right? You have to put it in standard form. This means to set the equation equal to 0, right? I want you to understand the ideas. These notes are garbage without your ideas, right? So again, so now we have 2x cubed minus 8x squared minus 90x equals 0. All right. So that's what we have here. Let's put a pause. All right, so we're back. What do I do now? We look for the GCF. Excellent. So that's what I always, even if there is no GCF, I write that in my notes. I look for a GCF. I keep practicing these good habits. All right. See, even the lights were shocked on that one. All right. So go ahead and factor out the GCF, and I want to see what you get. Check with your neighbors, see if they got the same thing. Ah, shit. I forgot to record. All right. So we factor that. So whoever's going to watch this later is like, what the hell did they just do? All right. So we factored. So let me bring this down so you guys could see. So if you missed it at home, all we did, we set this to standard form. So this we put in standard form in case you're lost. The lights went out. All right. Then we pulled out the GCF. And now we're about to find these mother factors, right? So that's where we're at. All right. It's like those TV shows. This is what you missed. All right, now we're back. So we get x, and some of us are getting really fast at this. Anybody know the two factors? Yes. Good. 5 and negative 9. What do we always do now that we found our factors? You set them what? Equal to 0. Write that down. Set each one of those factors equal to 0. Each one of those factors has to be equal to 0. So 2x, bam, that's equal to 0. X plus 5, bam, that's equal to 0. X minus 9, bam, that's equal to 0. So now solve each one of these. So here I divide by 2. Divide by 2, so I get x equals what? 0. I subtract 5. I subtract 5, so I get x is what? Negative 5. I add 9. I add 9. I get x equals what? 9. And then we write that in what notation? Set notation. So we write that in set notation. I'm going to try to slip it in here. We write our little set and put the numbers in order. Negative 5, comma 0, comma 9. All right, questions. All right, so let's look at this last Actually, not this last piece. I'm going to give you a nice one. All right. I'm going to give you a nice one just to see if you guys could take it before we look at this last example. Perfect. So the very first step you did was you set this equal to 0. So I imagine you subtracted 50? Perfect. So 8x squared minus 50 equals 0. And then you did what? You asked yourself what important question? GCF. All right. I'm gonna do something very dangerous right now. All right, here it is. So you got to really write yourself the right notes. Be very careful what I'm going to do here, because if you do this on the test, you could do it at the wrong time if you're not in the zone. Check out what I'm going to do. I divided every single one of these by what number? Did I divide by x? You can write this down. You could never divide by a variable. Right? Because I don't know what that variable is. You might be dividing by 0, which would be crazy. So you can never divide by a variable. Is this a variable? No, that's just a number. I have an equation. Can I divide both sides by the same number? Absolutely. I'm dividing by, in this case, is that the GCF? So in this case, by the GCF. What am I left with? 4x squared minus 25 equals 0. Doesn't that look a lot easier? Yeah, because that's now a what? I could use what formula? Good. So I could use the difference of squares. I could use the difference of squares. So I'm left with what? 2x plus 5 and 2x minus 5. So 2 times 2 is going to give us that 4x squared. Oh, this 2 over here, yes? I divided everything by 2 because I wanted to make those numbers smaller. All right. So now what? Yes.
So if you divide everything by 2, then the 2 could go away.
The 2 disappears. Exactly. Yeah, the 2 disappears.
Now they would just be dragged along.
Yes. If you factored it out, this 2 would still be on the outside. That would not be a wrong answer, and I'm going to show you exactly what would happen after we do this problem. I'm going to show you what that would look like. So notice, I totally got rid of the 2. All right. So now I do what with each one of these? Set them to 0. So now I set each one of these equal to 0. So I subtract 5. I subtract 5. I got 2x equals negative 5. Divide by 2. Divide by 2. So there's one of your answers right there. On this other one, I'm going to add 5. I'm going to add 5. I got 2x equals 5. Divide by 2. Divide by 2. X equals 5 halves. And I put them in what notation? In a set, right? I write them in a set. Yes. Always, please keep it in a fraction. Thank you for asking. Yeah. All right. So what I want to do now is I'm going to pretend I didn't do that stealthy move. All right. So what I want to do, don't copy this down, but just to show you. All right. So I'm going to squeeze it. I'm going to squeeze it right there. So I'm going to pretend I didn't divide everything by 2. All right. This is the part of our life when we ask, what if we did this? All right. You go back memory lane. 8x squared minus 50 equals 0. So most of us are probably thinking that you just factor out a 2, right? That's cool. You can factor out a 2 and you leave it on the outside. But here's the part we get confused on if we're not careful. So we bring the 2 down for the ride, and you get 2x plus 5. You get 2x minus 5. And now what do I do with all 3 of these factors? So notice this. We already know what this is, right? We know what this is. But does it make sense when you set 2 equal to 0? What does that mean? That makes no sense at all, right? So this is no solution. So that's why you don't even use that one. So regardless, that still would not be part of your answer. Does that make sense? But that's only when you have a number. Notice this does not have an x with it. So that's only when that's just a what? A number, right? All right. So the name of the game is always set one side equal to what? To 0. All right. So let me get you to practice one. Check your answers with the group, and I'll write your homework on the board. All right, here's the problem I want you to do. 2x, x plus 3, equaling negative 5x minus 15. Let me write that 15 again. 15. All right, solve that, and we'll see what you get.